Yes, I hope you're good at your end. I'm also good at this moment. And we are going to discuss about the properties of metals. Just as the normalcy, the norm of the day, we are at Iptikar Academy where learners get the best things. Now, this is a school that is situated at Feather Estate, Gate 2, Unity Court. If you are willing to join the family, please join us. We are a good family, and your child will come out from this place when nurtured and when he or she has occupied whatever he or she came for. Now, properties of metals. Properties of metals. Now, the last time we talked about metals and said elements with 1, 2, and 3 electrons in the outermost energy level are referred to as metals. Now, let us see within the periodic table. The metals, we have known them. We have seen how to find the metals. What are their properties? What are their properties? Now, what are properties, first of all? We have to understand the meaning of properties. The meaning of properties. Now, if anybody asks you, what are your properties? At some point, they can be possession. The property you have, or rather in a family, you are the son. I mean, you are the first, the eldest, or rather you're the last born. And then somebody comes and asks you, what properties do you have in this family? Now that is possession. But how about in science? We have properties of metals. What do metals have? What do metals possess? What do they own that qualifies them to be a metal? Yes, we want to look at what these metals have. In other words, properties are characteristics. We want to look at the features. We want to look at the characteristic a particular metal has. Any element that qualifies to be a metal, what are its characteristics? What are its features? What are its properties? Therefore, these are observable or rather measured characteristics. Measured characteristics metals have observable or measured characteristics metals have for identity. Of course, when you have wealth, you possess wealth, they will know. If it is a homestead, they will say there at Abtikafar or at Ibtikar, there are this and this. Yes, that is identity. They identify you by the name. Just like I said, at Ibtikar, we have services. We offer services. There are all available services that you'll want. We have them within the institution. So that is identity. They identify us with whatever we give to learners, whatever learners come and get and acquire. So that is identity. They know us. If it is in terms of academics, we excel. That is identity. They know that at Ibtikar, we offer this and this and this. That is identity. So we have observable, whatever that can be seen. Observe, seen, or measured. And remember, we always measure in terms of mass, kilogram, grams, tons, etc. or we can measure them in terms of the weight of something, or the mass of something that is measured, and then there are characteristics metals have. For what? Identity. They are basically for identity. For us to know that this particular element is a metal and the name of that metal is calcium, what do calcium have that we can see? Is calcium shiny? Is calcium dull? That is what we can see. Measured. In terms of how is it able to be drawn into wires? Can it break when we draw it? Ductility. Malleability. We are going to discuss about all those. So that is measured characteristics. For what? Identity. So after knowing that this particular element or metal can be drawn into wires, if you have a lot of wires and then you're able to roll that wire, draw it into wires, that particular phenomena is called ductility. And that is only found where? In metals. Remember, plastic cannot be drawn into wires. Yes, they will automatically break. But how about metals? You see a metal around you and then see how it has been manipulated into different shapes. It was heated, it goes into a state called molten state. Molten state. A state that is not solid and liquid, but it is in between. So molten state, and then the wire, the wire, or rather the metal, was drawn into any shape you wanted. If it is a love shape, yeah, it was drawn into that shape. If it is a circular shape, a rectangular shape, oval shape, and all those shapes, lobed shape, remember those are drawing metals into different shapes. So we are going to see observable characteristic, measurable characteristics that metals have for identity. And they include the characteristics include color, we have volume, we have shape, we have compressibility. In terms of compressibility, all these are state of the metal. State of the metal. State of the metal. Good. So we have color, volume, shape, compressibility. State of the metal or status. Number 2, we're going to discuss about ductility as another example. We have ductility. Another physical property, ductility. Another one is malleability. Another one is electrical conductivity. I don't know whether you're enjoying this. New things, new concept, enjoyable. That is how sweet science is. That is how aromatic science is, because we are learning new things each and every day, and all these things, we use them in our daily lives. Yeah, so that is electrical conductivity. And then we are going also to see thermal conductivity. Thermal conductivity. Good. Now, back to state of the metal. Let us begin with state of the metal. State of the metal as the first characteristics. Now, when you have a metal, let's say any metal you have around you, try to look at the shape. Can you define the shape? Yes, you can define the shape. If, for instance, the shape of that particular metal is circular, you can easily say it is circular in shape. If it is rectangular in shape. Cylindrical in shape. That is what we call state of the metal. State of the metal. Now, the three states of matter, we know them: solid, liquid, and gas. All the shapes, the color, the volume, the compressibility will bring us to the three states of matter, state of the metal. What is the state of that particular metal? Now, you consider an experiment with a metal and consider that metals have a definite shape. A shape that can be defined. This was taught in grade 8. They have a definite volume. And when you try to compress any metal around you, you will realize that they are incompressible. Incompressible. That is what you will realize. And then from there, we can conclude and say that metals, they are also shiny in appearance. We can conclude that metals are shiny in appearance. They are not dull. They are no longer dull. They are shiny. They try to captivate. You look at it and then you realize, wow, it is so interesting. Those are metals. Those are metals. So you look at the necklaces that you do buy, they are made up of metals. See how beautiful they are in terms of appearance. See how shiny they are in terms of appearance. So we can conclude that metals are shiny in appearance. Now, state of the metal, we can say as the answer to the state of the metal, say that metals are solid. Metals are solid at room temperature. At room temperature. Metals are shiny at room what? Room temperature. Temperature of the room. The temperature of the room around you will make the metal to be solid. The temperature of the room will make the metal to be solid. Unless or otherwise, there is change in temperature. If there is change in temperature, the state will automatically change. The state will automatically change. Now, state of the metal. We have seen that metals are solid at what? At room temperature. You touch any metal around you, you hold any metal around you, and you realize that it is solid in nature. It is solid in what? In nature. And that qualifies them to be incompressible. That qualifies them to be shiny and have a definite volume, have a definite shape. We know that all these are properties of what? Solid. That is why state of the metal, they are solid at what? At room temperature. Now, number 2 property of metal is ductility. Ductility. Now, in science, ductility means the ability of a metal, of a substance. So we don't know whether or element. So it can be a substance, it can be an element. The ability of a substance to be drawn into wires, without breaking. To be drawn into wires without breaking. That is what we call ductility. When I have a wire that is metallic in nature, and then I'm trying to draw it into wires without breaking. When I have a metal and I want to draw that particular metal into wires without breaking, that is what we call ductility. For example, we have copper. Let's say I have copper as a metal. Let's say this is copper metal. Copper metal. This is what? Copper metal. And then I try to draw copper metal into wires. without breaking the wire. This is what we call ductility. This is what we call ductility. So you realize that it is a metal. It's a metal, copper metal, copper metal, copper metal. And then you try to draw it into wires. You try to draw it into wires without this particular metal breaking. It is a metal. That is a property they have. A probability of a substance, element, or rather atom, metal, to be drawn into wires without breaking. That is a property they have. They can be drawn into any wire you want without them breaking. That is what we have as ductility. That is what we have as ductility. Back to the third one. Back to the third property of metals. Very fast. We move together, hopefully. If we are moving very fast, you'll comment down there so that next time I change my pace. So number 3, we have malleability. We have malleability. Sorry. Malleability. Now, the ability of a metal or rather substance, or rather an element, the ability of a metal to be hammered into thin sheets, is called malleability. The ability, into thin sheets. So if I have a metal and I want to hammer it using a hammer, from the word hammered, So you hammer them with a hammer, those metals, and then you break them into very thin sheets. Yes, you break them into very thin sheet. That is what we call malleability. It is only the metal that will be hammered and turned into thin sheets. Or rather, you can press the metal. You can press the metal. So if you are able to press or hammer a metal and then it turn into a sheet that is very thin, not thick, that is malleability. So metals have that ability of being hammered, of being pressed into thin sheet. That is what we call malleability. Example of such metals are aluminium. We have copper, etc. Now, number four, property of metal. That is thermal conductivity. Now, thermal comes from the word to heat. So thermal basically means to heat. Whenever you heat something, that is thermal. Whenever you provide heat, that is thermal. Conductivity, the ability of that particular metal to allow heat to pass through it, to contact heat, that is conductivity. It is able to move heat from one point to another, allow heat to flow through it easily. Thermal conductivity. So thermal means heat. So it means when I heat a metal, heat can flow from one end to another end. Now, for instance, using a diagram, we can easily explain this. I'm not good at drawing. That is not an excuse, but that is what is there. But we have to try. Basically, in science, we have to sketch. We can be able to always sketch. Now, thermal conductivity. Thermal means heat. What is it? The ability of a metal. to conduct heat, or rather allow heat to pass through them is called thermal conductivity. The ability of a metal to conduct heat is called thermal conductivity. Allow heat to pass through them. Allows heat to pass through them. Allows heat to pass through them. Allows heat to pass through them. Now, there are those metals, all of them, they are able to allow heat to pass through them. Now, for instance, I'm doing an experiment to demonstrate. Thermal conductivity. I'm doing an experiment to demonstrate thermal conductivity, and I have the following. I have a stand and a clamp. That is one. Number two, I must have a source of heat. In this case, I'm going to use Bunsen burner. Or a candle. And then I'm going to have the metal wire. That will allow me conduct my heat. And then I'll have, let's say, I have a pin as another metal, and I have a wax there to see whether this is the experiment in consideration. Now we're going to have wax if it is able to melt or remain solidified the way it was, remain solid the way it was initially. Now it is the experiment of study. It is the specimen of the study. Now, experiment to demonstrate thermal conductivity. I have the following. I want to arrange them. Now, I'll arrange them in this manner. I'll have my stand with, I began by saying I'm not good at drawing, so you'll forgive me about that. But this is the true representation, the diagram of what the experiment need. So I have a clamp with me here. So this clamp is holding a wire, metallic wire. So this is the metallic wire. To that point. So my clamp is with me here. My stand, I mean. So I have my stand. So this is the stand. So it is clamped here, my clamp. And then this is the metal wire, be it copper wire, be it zinc, aluminium, calcium, sodium. So this is the metal wire. And then there is source of heat at this end. The source of heat is here with me. In this case, allow me use Bunsen burner with chimney, and then I have my, allow me draw it at the other end so that they don't get into contact. You can see my flames. Always remember that the blue part is the hottest, blue region. In a flame, the blue region is the hottest. So when I have the chimney, and then next is the collar with air hole in between, and then I have the base. I have the base. Good. So this my flame can be always non-luminous, which is used for heating. Non-luminous flame used for heating with only 3 regions. And then I have my gas pipe somewhere here, and hose pipe, gas inlet, and rather gas hose. Now, this is a sample experiment. Where's my wax? Let's say I've placed my wax here, the solid one. The solid wax is here, and then there is a pin that has been inserted on the wax. So this is wax, and this is the pin. This is the far end of the wire. Sorry, far end of the wire. Metal wire. Now, look at a sample experiment. A sample experiment. We have metallic wire, we have a clamp, we have a stand, source of heat, pin is there, that is wax, that is far end of the wire. Simple experiment, as simple as that. Now, I said that thermal conductivity is the ability of a metal to be able to allow heat to pass through it easily. So when I heat this particular metal, there is source of heat and there is a metal. Will it allow the heat to flow through it from this end to the far end? Will it allow? Yes. That is what metals are. Property of what? Metals. So they will allow heat to pass through them. Now, when I do an experiment, always there is an observation. There is an observation. And we have to also explain and conclude what the experiment is all about. Now, in this particular experiment, we were trying to demonstrate thermal conductivity. And when you heat the metal wire, what happens is that the wax here will melt. The wax will melt. And when you hear the word melting or melt, it means it is changing state. Changing state. From where? From solid to liquid. And that is what we call melting. That is what we call melting. Now, once this particular wax has been heated, it changes from solid to liquid, and the pin automatically will fall down. So what is our observation? What is our observation? So we can say the wax melts, and the pin falls off, and the pin falls off. That is our observation. That is what we are going to see. Immediately you allow the source of heat to provide heat. The wire, after some time, will conduct heat. And what will happen? The wax will melt and the pin will fall. The pin will fall off. Now, how can we conclude? Conclusion. We can conclude by saying the metal wire allowed heat to pass through it, to flow through it, that is conducting from one end to another end, the far end. It allowed heat to pass through it, that is conducted heat from one end to another end. In other words, it absorbed some heat, it got some heat, and then it was able to move the heat from one end to the far end, and then automatically the wax solidified and the pin fell off. Now that is our conclusion. We can conclude the same metal wire allowed heat to pass through it or flow through it from one end to another end. This phenomena is called thermal conductivity. The phenomena is called thermal conductivity. You can always pause the video so that if you want to jot down some notes, you are able to. Now this phenomena is called thermal conductivity. Thermal conductivity. This phenomena is called thermal what? Thermal conductivity. Now the last property is electrical conductivity. Yes, this is the last one. Remember, we talked about the state and we have said they are solid in nature. And I also forgot something which I will add and state at the end of the lesson. We have again talked about ductility as the second, and we have said the ability of a metal to be able to be drawn into wires without breaking. The likes of aluminum, the likes of copper wire, that is called ductility. How about malleability? I have said that malleability is the ability of a metal to be hammered into thin sheets without breaking. And we have again conducted an experiment theoretically. Of course, that is funny. Conducted an experiment theoretically, and we have seen that they are able to conduct heat, and that phenomena is called thermal conductivity. Now let us see the fifth one, electrical conductivity. From the word electrical, we get what? Electricity. And when we hear the word electricity, what comes into our mind is electric current. Electric current. And what do? They flow. They flow. For us to have the light, it means there is electric current flowing from the source of electricity. And the source we talked about water. Water is where electricity comes from, wind or solar. So you get all this, sun for the solar. Now we look at all these and realize that they give us current, electric current. If it is water, hydroelectric power, talk about water being heated to steam. The gaseous form of water is concentrated on the turbines. The turbines later on rotate. Currents are being taken onto the transformer, and then we get the electricity. Now, electric conductivity. Are metals able to conduct electricity. Now, this is the ability. This is the ability. This is the ability of a metal to allow electric current to flow through them, to flow through them easily. The ability of a metal to allow an electric current to flow through them easily. The ability of a metal to allow electric current to flow through them easily. Copper wires. Copper wires. Now you realize that these metals, they are again able to allow electric current to flow through them. The current is able to flow through them. Look at the casing of those copper wires that are at your homestead. Those particular wires are allowing the current to flow through them. That is why we have electricity. So they are able to conduct electricity by allowing the electric current to flow through them. That comes or calls the end of our subtopic properties of metals of today, and I would love to add one thing. Under state of metals, we said that metals, it was number one, that metals are solid at room temperature. They are solid at room temperature. That is what metals are. Except, I want us to add this, except, unto your medulla oblongata, I wanted to add this. Don't worry about the term. Metals are solid at room temperature, except mercury. Mercury, which is liquid at room temperature. I know majority of your teachers won't remember the mercury. Mercury is liquid at room temperature, and it is the only metal that is liquid. In an examination, if you ask to mention the only metal that is liquid at room temperature, kindly consider mercury. The symbol for mercury is Hg. The symbol for mercury, Hg, standing for hydrargyrum. That is the symbol for mercury. Now you know that all metals are solid at room temperature, except which one? Mercury, which is liquid at room temperature. Thank you. Bye-bye. The end of the subtopic.